Today we are going to talk about continuous functions. Okay? Yes. Talk about continuous functions. So, with our continuous functions, we're going to do a little fill in the blanks giant notation. Okay? I want y'all to consider this is a trivia that I gave you fill in the blanks. Yes. Okay? You get a little breather. Don't worry. We will have. Huh? You should have picked it up when you came in. It's double-sided. Try to save trees. So I took 3 papers and turned it into 1. Oh, okay. See what I did there? Yeah. I care about the environment. All right. So here we go. So with the gist of this one, remember that blank refers to the x values. What refers to our x values? Domain. The domain. Oh. Why am I in a highlighter? Little part. The domain refers to our x values represented in a problem, and the range refers to the y values that are represented in our problem. That is what we focused on reviewing last week, right? And just now during our do now. Are we all comfortable with that? Domain means x and range means y. Good to go? Yeah. All right, here we go. Sometimes it isn't possible to list all values that x or y can be, because the graph is, what do you call something that goes on forever? Infinite. Infinite, but if I'm like touching it and I have no breaks in it, it starts with a C. It's continuous. It's also the title of your notes. The graph is continuous. Okay? And made up of and someone said it, forever, infinite. I heard it somewhere in there. Of an infinite. Are you sure? Oh, okay. Infinite number of points. Like a, how many of you had geometry last year? Okay? What is made up of an infinite amount of points in geometry? It's the first vocabulary you learned.
I don't know.
Huh? Good luck. Oh, I couldn't say it. Good job, Jay. What's line?
Yeah. I wasn't paying attention.
A line is made up of an infinite amount of points, right? Okay, and there are 2 variations of a line. A ray and what else? Not a plane. One more. So a ray.
Hey, that's my name.
A segment.
Good job. Oh, Jay.
Oh, I'm cold, boy.
In a segment. We got a ray and a segment. Okay? Can I bring it up? Is that okay? And no one's writing what's at the top, right? All right.
It's neat how that stays on the line.
So sometimes we have to represent it. Because think about it. If you have a number line between 0 and 1, you have a bunch of numbers, right? You have 0.01. Then you have 0.001, and then 0.0001, then 0.000001. Okay? And they keep going. So there's no way you can list out all those values, right? So that's what we mean. You have a continuous function. So when you're determining the domain of the continuous function, how do you think you define your domain? What directions would you go to define the domain? Find the domain. Which direction do you go?
Right.
I heard something.
Right.
Left to right.
Left to right. We go from the left to the right. So we're going to go left. Left to right, which essentially is going to go from small to our large, big. I'm going to be lazy and write big. That is such a tiny G on that word, big. Okay, and a continuous graph, when you want to define the range, which direction am I going to go?
Right to left.
Is it top to bottom? Bottom to top.
Bottom to top. We're going to flip it. We're going to go from the bottom to the top. Because we want to get our small, then our big. So what we're going to focus on today is using algebraic notation / also called inequality notation. So we're going to use inequality notation.
That's a big one.
I-N-E-Q-U-A-L-I-T-Y. Inequality. It started off that way, didn't it? I didn't mean to do it on purpose.
But then it was short. There was
It
like,
did. I was like, wait, why did you do that? So we're going to use inequalities to represent our domain and range. Remember, your inequalities are your less than, greater than, less than or equal to, or greater than or equal to signs. Those are our inequalities.
What about equal?
That's our equality sign. Make sense?
Well, I'll just ask this.
Good question. Hey, you're not alone. Okay? Alright, he's just jealous that he didn't ask it. Alright, so we're going to switch to the right side. So we're going to focus on the right side. I'm going to apologize right now that on your right side, your lines did not
Ms. Jones.
come out.
Oh, I was gonna tell you hold
Hold
on.
on. All they did is
Cause remember, I'm trying to type this down.
Yeah, oh no, I was going to print this for her.
Oh, yours?
Yeah.
Oh, okay.
That's the beauty of this. I'll print it.
Okay.
So get down whatever you can, and then I'll print the rest.
Okay.
Okay? I meant to tell you that.
hanging there.
Alright, so I'm going to apologize. So you see how like I have these pretty little grids?
Man, the thing cheap.
Right? And then you don't have these pretty little grids? I think you'll survive.
Gotta get your money.
We'll just modify it, okay? So sorry about your paper. Alright, let's fill in our blank. So, and blank tells us the point is blank. Well, you're like, what is the blank? An open circle. So in this blank, you're going to write open circle. Tells us that the point is, think really hard back to that good old Algebra 1. What does an open circle mean on a graph? Not what?
An actual point, like
Not an actual point.
Not an eighth value.
So it's not,
A number.
huh?
No.
Not included? Did you whisper that maybe?
I said it's not equal.
It's not equal, it's not equal, it's not included. It's all, y'all are so good. It is not included. So it's not included in the solution. There's a hole. There's a hole in my function, okay? It was kind of like from Toy Story. There's a snake in my boot. Exactly. So we use the strictly less than and strictly greater than. So here's my less than, and here's my greater than.
I always get them too confused.
Oh, a good way to think about the less than is it kind of looks like an L.
Oh, so that's how I read it?
Oh, less and I can
Less than kind of makes an L.
Ah,
See it?
because of L.
Uh-huh. Because you know the L faces that way. Maybe that'll help you.
Ligature sounds like a gay word.
Because it looks retarded on his face. What word?
Well, let's just.
What does he say?
I don't know where that came from, so we're just going to move on. Less than, greater than. So on your blank space, since you don't have lines, we're just going to draw an example. So an example would be if I had this ray.
Yes, you.
Notice that my starting point is a open circle. So my starting point is not included as part of my solution. Does that make sense? Whatever that value is, it is not included as part of my solution. Okay? Questions, comments, concerns?
So you got it?
Mm-hmm. Another example is that you could have a segment, and on your segment, you have two open circles. That means that the starting and the ending are not included as part of your solution. And lastly, we will dive further into this as we go throughout the year. You can have a line with a hole in it, and that means that there's one point on that line that is not included.
What the whole line is.
The rest of it is that one point, there's a hole in my function.
So
That's where that comes in.
in.
That's where that comes into play.
Wait, so you saying there's always a hole?
No. There are certain functions that will have a hole in them. And we will learn about those functions this school year.
There's a new
Don't worry.
What would you say?
Coming spring of 2019.
Oh my God.
That's when.
It's a snake in my leaf.
That's a long time.
There's a J.
It's really nice to think about it. It's like right
I
around
want
the
to think
corner.
No.
about J.
Alright, here we go. So, if we just talked about an open circle, what do you think we're talking about now?
Close.
Oh my gosh, I'm so smart. A closed circle. So a closed circle tells us the point is if open is not included, closed is included. Okay? So in the solution, so we use, instead of strictly less than,
Less than anything.
perfect, less than or equal to, or
Greater than equal to.
greater than or equal to. So I'm going to tell y'all like my little greater than or equal to way of remembering. So you see this one right here? This one has an empty tummy, right? So hungry, tummy's empty. This one has a Snickers bar, so his tummy is full.
Sneakers every
Ta-da! So if I have a bar, I'm full. If I don't have a bar, I'm starving. I'm hungry. That's how I remember it.
Yeah, it's Sneakers every
Exactly. The Snickers satisfied this whole.
You know.
Alright. So, again, if I had a rate, its starting or ending point would be included. In this case, it would be my ending. I could have a segment, and on that segment, the starting and the ending would be enclosed, which means that they would be included. Can you have a combination on a segment of an open and a closed?
Yes, you can.
Yes, you can. I'm glad you know that. Okay? All right, what's the last type of end behavior we can have? So we've had open, closed. Which one are we not talking about?
Right?
What's at the end of array?
A segment.
We haven't talked about arrows, have we?
An arrow.
So what if I have an arrow? What does that mean? So if I have arrows,
Oh, we at the bottom of it.
it goes on forever, right? That means your X's and Y's are going on forever. Forever. Okay? Name the movie. Nobody?
What?
Nobody?
Oh,
Say it again.
Forever.
shit.
Harry Potter.
Harry Potter.
The Sandlot.
Sandlot.
I didn't watch that.
I've seen that movie like 7 years ago.
Y'all are losers.
I seen the movie a lot of
We're
times.
gonna
I
move
just haven't
on,
seen it.
and y'all be losers.
I don't watch movies,
Okay.
so I don't know.
So, if I go on forever from the left, well, my left, my right, from the left to the right, what is forever called in math?
What kind of
Infinite.
Infinity. So if I'm going to the left, what kind of infinities are those?
negative?
Negative. And if I go to the right,
Positive.
positive. So my negative, I'm going to tell y'all, my infinity symbols struggle.
Infinity War?
They just
Oh,
struggle. They just never, you know, I've tried to make it into Harry Potter glasses. I've done everything I could to try to make them work, but for some reason, they don't work. So when I get tired of trying, I just draw two circles next to each other. And that's what they're
Just like,
Okay.
let's start at the top.
It's like a figure eight.
Yeah, see, you got it there.
Let's close it out. Okay? So don't judge my infinity symbol. I won't judge yours. Okay?
Just turn it like this and then
It's
draw it.
just
How am I
turn
going to
the
turn the
board.
So
board?
it's just a
Oh.
little, just a little point. You should look.
It's
How am I going to turn the board, Jalen?
All you gotta do is flip that.
Turn
It
your
doesn't
head.
make sense.
Mine is good.
So infinity means that I have arrows at both ends, right? And I'm going on to infinity and beyond.
Toy Story.
Good job.
1, 2, and 3.
I had to quit.
He thought you were
I broke mine. I'm not.
All right. Any questions so far? All right. So we're going to apply our knowledge. So you're going to flip the paper over, and you're going to see where it says I do, we do, you do. Okay? So the I do is me up here, and you guys are going to kind of like guide me. Okay? The we do is I'm going to call on you, one of you, 3 of you, to come to the board, and you do it.
Oh my god.
Okay? Up there, we as a class. So even if you don't know how to do it, your class is going to help you.
Then you do the
Okay?
other ones.
And then the you do is you, the student, by yourself, flying solo.
Yeah, that's what it say. It say you do.
Exactly.
You do.
You read it. Okay? Okay, so a random, I know this is distracting. So my son, I was like teaching him to say thank you all the time. So he's like, okay,
Thank you or something.
thank you. He says thank me. So when someone does something for him, he says thank me, thank me, thank me. Because I was like, say thank you. Okay, thank me, thank me. So whenever I'm trying to do something for him, thank me, mama. Oh, okay. And I can't get him to stop. So how he walks out the toilet.
At least he has manners.
He does, but it just comes off wrong. So that the whole pronoun business throws us off, right? Try to teach it to a 3-year-old. All right, so we're gonna do the first one together.
I gotta start doing that thing.
Okay. All right. So here we're gonna talk about domain. So D and R. D stands for domain. R stands for range. We're good with that? All right. So we're gonna start with our domain. According to our notes, which direction do we read our domain?
Left to right.
Left to right. So if I go all the way to the left, what do I see?
Arrow.
An arrow. What does an arrow tell me?
Arrow.
Infinite, right? So if I'm going to the left, what kind of infinity is that?
Negative.
Negative infinity. So I'm going to write negative infinity. And when you write infinities, it is strictly less than, okay? They don't get a bar underneath because you can't stop infinity, right? So you can't include it because you can't contain it. Does that make sense? All right, and so we're talking about domain. So my middle is what I'm describing. I'm describing my x.
I did this like freshman.
I got like one nose.
Okay? So then if I'm going to go to the right, and I go to my right, and what do I see?
An arrow.
An arrow, right? And so what does that tell me?
Positive.
It's positive infinity. So if I go all the way to the right, that is my positive infinity.
I messed up.
Can someone tell me what does negative infinity to positive infinity represent in words? I heard it. Good job, Manny. All real numbers. You want to know something? You are the first person to get it right all day.
I could have said it,
I
but
was
he didn't
going
get
to
the
say
time.
it, but like he said.
Oh, really?
I'm like for real, like I was definitely I'm not sorry.
All real numbers. So if I have from negative infinity to infinity, that means that any number I plug into this function will produce a solution.
So point two.
Got it? I can't really read it like that, but you get what I'm saying. Okay? I'm trying to make you prove it right now. All right, so my range. So range, how do we read it?
Top and bottom.
Bottom.
Bottom to top. So I go to my very lowest point. So this is my very lowest point. I don't know what it is. I think it's at, is
3.
it 0, negative
two.
3?
3.
Three.
Negative 3.
Negative 3, right? So we're at 0, negative 3. So what is my lowest y value?
0.
Y value.
Negative.
The negative 3. So I write negative 3. Is it included in my graph or is it a hole? It's included, right? A hole will be very obvious. So if it's not like a, look, here's a white space, that means it is included. So I'm going to make it a full. Got my little Snickers. Okay? And what variable are we defining right now?
Q. Not Y.
Our y. So now I'm going to go, I already started at the bottom, now I'm going to work my way to the top. So I go all the way to the top, I'm like, oh look, there's arrows. So what do those arrows mean? If I'm going up forever,
Infinity.
what kind of infinity?
Okay,
Positive.
Positive.
teachers and students. Students, just a reminder, tardies start tomorrow. Tardies start tomorrow.
All right, here we go.
She was tired.
Yes. So, where were we at, guys?
It was
Oh,
on
we
number
finished,
two.
right?
Can we just do go to the bottom?
So we're going to number 2. Oh, so you don't need me anymore? Is that what you're saying?
No.
Just trying to kick me off?
Never mind. We gotta do them. I don't know how to do those. So we gotta do them.
Oh, okay. So, domain again means we go left to right. So when I go to the left, what do I see?
Negative.
Negative infinity.
Perfect. Negative infinity. Less than. And what's my variable I'm defining?
Not what I
Are you being serious?
No, I'm serious.
All right, so I travel along to right.
You include that one.
It is included. And what is it?
7.
7 what?
A segment.
Like what?
7x.
How much over and up? What's the coordinate? Is it 7, 4? Or 7, 5?
5.
I think it's 5.
It's 6 and 5.
Is it 6?
Ooh.
We got multiple 6s. We'll let 6 win. All right, so we have 6 and 5. So which of those is my x value?
6.
6. So is it included or not included?
Included.
What is?
So that's the
Boom.
answer.
Domain row.
actually.
Was that difficult?
Mine.
Just a little bit.
Yeah.
Okay, let's keep
It
going.
wasn't easy.
It wasn't easy, but was it difficult?
Yes.
Hall of Fame.
Medium.
Range. So range, so from bottom to top. What is my smallest, my lowest y value? What is that coordinate?
-4.
1, 2, 3. Is it 3? -3, -4?
No, it's -4.
Yeah, -4, -4.
-4, -4.
Y'all got -4,
I
-4?
can't see.
Use your glasses.
These lines, I can't see either. So -4, -4 is what we're going to go with. And so what is my smallest y value?
-4.
-4. Is it included or not?
Yes.
Good job. And I'm defining y. And as I go all the way up, what do I run into?
2.
The arrow.
An arrow. So what does that mean?
I mean infinity.
Infinity and beyond.
Rock with it.
Yes?
No.
What's the problem?
Let's go one more and see if we get it.
I know, it's our last one together, right?
Yeah.
So on our last one, we have what's called a split domain and range. How do I know it's split? Because my graph is split, right?
Yes.
It's called a piecewise function. We'll dive deeper into it. But right now, we're just going to focus on what the function is. So when that happens, just cover it. Cover one, work on it, and then uncover it and do the other. Okay? It's magic.
Can I do that too?
Favorite part right here.
All right, so when I look here, I'm going to do the same thing, left to right. So my left is at -infinity. And then I go over here and I think, what was this?
Do you want us to turn this in or put it in the folder?
That's included.
Included.
It's included. So what's the value? Is it -2? Is it -2?
-2, -4.
Okay. So -2, -4. So that domain is done. I'm going to put a comma because I know that there's another part to this graph. Does that make sense? And I'll come back to it. Remember we covered it? So we got to go back to
There's
those.
2 parts.
There's 2 parts. So I said it's split.
Oh, shoot.
Wow. Okay? So now we're going to do our range of this part. So my range, my arrow is going down. What does that mean?
Infinity.
What kind of infinity?
Negative.
And then my highest point is here at -1, right? So then it's also included at -1. So that is the domain and range of that part of the graph.
Now we got 2 parts.
Now we have to do the other part.
This don't make no sense.
It do.
So I'm gonna take this, cover it, and look at the other part. So on the other one, the range,
Bottom to top.
bottom to top, right? So my lowest point here this time is 0, and it has an arrow that goes on
Forever.
forever.
So it's positive.
So it's positive. So we have from 0 to positive infinity.
You got a minute.
And, oh, we're gonna do it. We're gonna finish the ID.
Come on, so nothing.
All right, and then what's my domain? Left or right?
Right.
Man, that's
Okay,
1.
what's my right? What's my
That's
left
2.
side value? Is it 2?
That's 3. No, 2
Is it 2?
Man.
So I have 2. Is it included or not included?
Not.
Not included.
All right, I'm
And then it goes on where?
to the 8537.
What's that called?
Infinity.
Infinity. All right, good job, guys. We finished the I do. Tomorrow after your quiz, we're gonna do the we do and then the you do. Got it? Great.
Forget about the quiz.
No, we can't forget about it.